Okay, in our third lesson on graphing rational functions, we're going to put together what we've learned about vertical and horizontal asymptotes and use those along with a little bit of other information to help sketch the graph of our rational functions without the use of a graphing calculator. And so they've listed here for us the steps that we need to follow to graph these rational functions. And so the first thing it says we want to do is factor out all the polynomials that can factor. So that means both in the numerator and the denominator, we're going to factor. Then we're going to find the domain, and remember the domain comes from setting the denominator equal to 0. Then we're going to find our horizontal asymptotes. Remember those come from our rules, the ABC rules. And then we're going to find vertical asymptotes using whatever we found from our domain. Remember, whatever you have excluded from the domain, those are your vertical asymptotes. And then we're also going to find our x and our y intercepts. And remember, x-intercepts are where y equals 0, and y-intercepts are where x equals 0. And so we'll talk about how to solve for each of those. And then we may have to find a few other points as we go, but we'll talk about that in a minute as we get through our examples. So these are our steps we're going to follow. So let's take a look at our first example. So the first thing we are supposed to do is factor. And this numerator doesn't factor, but the denominator does factor. It's a difference of squares. So it factors to x plus 2 and x minus 2. So for our domain, we're supposed to take, since this doesn't reduce, it's in reduced form, we're supposed to take our denominator and set these factors equal to 0 and solve. And so I'm going to get x equals negative 2 and x equals positive 2. So our domain could be anything except x equals plus or minus 2. And whatever we have excluded from our domain, that becomes our vertical asymptote. So we have two vertical asymptotes, one at positive 2 and one at negative 2. Remember, vertical asymptotes and horizontal asymptotes are lines, so it needs to be an equation of a line. So x equals 2 and x equals negative 2. Our horizontal asymptote comes from our rules, and our rules state that when the exponent in the numerator is smaller than the denominator, then the horizontal asymptote is y equals 0. And those are the rules from the 5-2 notes yesterday. Okay, then it says we want to find x and y intercepts. Well, to find the x-intercept, we're going to put 0 in for y. Now, there's actually a little bit of a shortcut for this, but let's go ahead and work it out first. If I put 0 in for f of x or for y, I get 0 equals negative 2x over x squared minus 4. Well, to solve that, the first thing I do is multiply both sides by x squared minus 4. And on the right-hand side, they divide out. Over on the left-hand side, I just get 0. And that's going to happen every single time. The denominator is just going to equal 0 on that left side when I'm multiplying. So the denominator doesn't equal 0, but it divides out over here. And on the left-hand side, I'm always going to get 0. And because of that, our shortcut could be to just set the numerator equal to 0. So when you're looking for an x-intercept, if you will just set the numerator equal to 0, it will save you this first step. So now I've got negative 2x equals 0, divide by negative 2, x is 0. So x is 0 when y is 0, or I have the point 0, 0. Then for our y-intercepts, we're supposed to put 0 in for x. So I have negative 2 times 0, right here, 0 squared minus 4. So that gives me 0 over negative 4, which is also 0. So when I put 0 in for x, I got 0 for y, or I got the exact same point. Now, they're not always the same points. In this one they are. It's actually helpful if they are not the same point. The more points we can get, then the less we have to do test points later. But they are this time. They give us the same points. So now we're going to try to put some of this information over here on our graph. So our horizontal asymptote is y equals 0. That is our x-axis, where y equals 0. So we get our x-axis is our horizontal, and then our vertical, we have two of them at positive 2 and another at negative 2. Okay. We also have this x and y intercept that is at 0, 0. Now, I don't know if you guys got to any of your rational functions information last year, because I know we had to cut the year short. But an asymptote, normally, when we talk about them in mathematics, we say, well, you approach an asymptote, but you never actually cross it or touch it. Well, we can see right now that we are touching and crossing this horizontal asymptote. So here's the deal with rational functions. I want you to write this stuff down. You are never going to cross a vertical asymptote. You will never cross a vertical asymptote. However, you may, because not always, but you may cross a horizontal asymptote one time. You will never cross it more than once. So, in this case, it looks like we are going to cross it, or at least touch it that one time. And so when you do that, that kind of throws some things into play that won't happen otherwise. Because if we are just approaching these asymptotes, these vertical asymptotes divide this graph into three sections. We have one section here, two would be this center section, three. So there are going to be three curves, a curve in each section. There will not be a curve in the top and in the bottom, because remember, we are only approaching these asymptotes, never touching them or crossing them again, because we've already crossed here. So there will either be a curve at the top or at the bottom, but not both. In this middle section, there might be a curve at the top that comes down kind of like a parabola, or maybe a negative parabola that does this, or maybe it's going to look more like a cube function graph or a negative cube function graph. But there's only one curve, and the same on the right-hand side. So we have to figure out where those curves are, and in order to do that, we're going to have to run test points. So I'm going to make a little t-chart here for some test points. So we're going to start over here on the left. We're going to try a point in this left section. So I'm just going to go with the next point over, which is negative 3. If I put negative 3 in here for x, negative 2 times negative 3 would be positive 6. Negative 3 squared would be 9, minus 4 would be 5. So I get positive 6 over 5, or positive 1 1/5. So when x is negative 3, I go up 1 and just a little bit more. So I have a point in that section of the graph. And that means that from that point, I've got to approach each of these asymptotes. And I can't cross them, so that's it. That's where the curve goes in that particular section. So now we want to do that for the center section, but since we don't know if it's coming from the top or the bottom, we're going to try negative 1, and we'll also try positive 1 on the other side of our point. So when I put in negative 1, negative 2 times negative 1 would be positive 2. And negative 1 squared is 1, minus 4 would be negative 3. So I get negative 2/3. So negative 1, negative 2/3 lets me know that from here I have to be approaching the asymptote that's on the left. Then when I put positive 1 in there, I get negative 2 over negative 3, which is positive 2/3. So 1 positive 2/3 lets me know this section is going up. So in the middle section, it does look kind of like a cube function graph. Now we have one more section to go over here on the right. So I'm going to pick 3 to plug in. Negative 2 times 3 would be negative 6. Negative 3, that 3 squared would be 9, minus 4 is 5, and I think I plugged in a negative 3 there as well. No, I didn't. So negative 2 times 3 is negative 6 over 5 would be negative 1.5, or negative 1, negative 1.5. So our point is going to be at 3, negative 6/5, and we have to approach the asymptotes, so my curve is in the bottom section. Now, the more x and y intercepts that you have, the more points you get, the fewer of these test points you'll have to do, but you are going to have to run some test points to figure out what's going on in each of the sections of our graph that are created by your vertical asymptotes. In our second example, we're going to follow those same steps. So the first thing we want to do is to factor. So to get 2x squared, it's got to be 2x times x. To multiply to get 6, we're going to need to use 3 and 2. It does matter where you put them. So I'm going to place them here. And remember that gives us a 4x on the outside and a 3x on the inside. So the 4 needs to be negative and the 3 positive in order to get a negative 1 for the middle. And in our denominator, this is a difference of squares. It's tempting to switch those out, but remember this is a negative x squared, so I think I would just leave it alone, factor it as it is. So 9 would be 3 times 3. X squared would be x times x. 1 is positive, 1 is negative. So everything is factored out. We're supposed to reduce it if we can. This one does not reduce. So now whatever's in the denominator, we're going to use that to solve for our domain. So here we would get x is negative 3, and here x is 3. And so our domain is all real numbers except x cannot equal plus or minus 3, and both of those would become my vertical asymptotes. All right. For our horizontal asymptotes, we're supposed to use the rules, and here we have x squared in both the numerator and the denominator, so we're supposed to use the coefficient in front, and here it's 2. Here it is understood to be a negative 1, so 2 over negative 1 gives me negative 2. Y equals negative 2 would be my horizontal asymptote. So we're going to use that in a minute to help sketch our graph, and in addition to that, we want to find our x and y intercepts. So here we go. Remember, for our x-intercepts, we said the shortcut would be to set the top or the numerator equal to 0. So I'm going to take the factored form of the numerator, 2x plus 3 times x minus 2, and set it equal to 0, which means that I'm supposed to take each of these pieces, set them equal to 0, because either one of them could be 0. Here I get 2x equals negative 3. Negative 3. Divide by 2. X is negative 3/2. Here x is 2. So I have two x-intercepts, one at 2, 0, and one at negative 3/2, 0. For the y-intercepts, I'm supposed to put 0 in for all of the x's. That's probably easiest in this original form. So 2 times 0 squared minus 0 minus 6 over 9 minus 0 squared. Well, 0, 0, 0. I get negative 6 over 9, which reduces to negative 2 over 3. So my y-intercept is 0, negative 2 -2/3. All right, so there's all the information that we have. We do have a few more points to work with this time. So let's go ahead and sketch what we've got. We have a horizontal asymptote at -2. And we have vertical asymptotes at +3. And at -3. Okay. And we have some x-intercepts. We have an x-intercept at 2, 0. And at -3 has our -1.5, 0. And then we have a y-intercept at 0, -2/3. So here's what I was talking about. We still have 3 sections of a graph. We have a section here, a section in the middle, a section to the right. And I don't have any points out here on either of these, but in this center section, I've got 3 points. And you can tell that the curve has already made its turn. So we already know what's happening in this middle section. It's going to look a little bit like an offset parabola. So we don't have to do test points in those 2 sections. But we are still going to have to run a test point on the left and on the right. So all right, so I'm going to put in -4. So if I put -4 in here, maybe the factored form might be a little bit easier. I don't know. So we'll use the factored form. So I'm going to get -8 plus 3 is -5. And over here, -4 minus 2 is -6. Over, and then -4 in here. 3 plus -4. 3 minus 4 would be -1. And then 3 minus -4 would be 3 plus 4, which is 7. So I end up with 30 over -7. So 30 divided by -7 is going to go in there -4 with 2 left over. So when I go over here to -4, I get -4 and a little bit more. So my point would be down here, and that means if I'm approaching these asymptotes, that my curve is in that section. And we'll do the same thing over here with +4. So I'm going to put +4 in my equation. This would be 8 plus 3 is 11. 4 in here, 4 minus 2 would be 2. Over 3 plus 4 is 7. And 3 minus 4 would be -1. So I get 22 divided by -7. Well, that'll go in there -3. And we're going to have 1 left over, -3 1/7. So when I go to 4, +4, I get -3 1/7, which still puts this in the bottom section of that portion of my graph. So a curve in each section. And that's it.